Hi, this is Professor Pradyot from Leadib Academy. Okay. So we are going to discuss IBDP Chemistry HL Paper 1 of May 2019. And I have mentioned this paper number for your ready reference. Okay. So what is going to be interesting that for this specific paper, paper 1, I'll not be just mentioning the solutions, okay, but I'll be explaining the underlying concepts so that your understanding would be clear. Because typically in paper 1, many students struggle, okay, because many times they just get the solution or just the option, but they don't get the actual underlying concepts. So I'll be trying my best to explain the underlying concepts so that it would be very easy for you to handle or tackle similar questions. Okay. So what we do at Leadib Academy, basically we are one of the leading IB coaching institute. Okay. So what we do, we are providing the courses on the various subjects. So link has been provided in the description. Besides these courses, we do provide the one-to-one online teaching. So you can take the benefit out of that. So in short, we are specialists of IB diploma. Okay. So I hope you will enjoy this paper 1 solving. Okay. So let's start looking into the various questions. Okay. Okay. So let's begin with question number 1. So we have been shown these 4 different diagrams, and they are asking us which is representing the heterogeneous mixture. What it mean by hetero? Let's start understanding what it mean by heterogeneous. Heterogeneous. It means that 2 different phases. Okay. So phase number 1 and phase number 2. So it can be, one can be liquid, another can be solid, or liquid and gas, etc. Okay. And these 2 phases are existing separately. Okay. And obviously they can be separated by some mechanical means like filtration or simple. Okay. There is no chemical reaction, but by physical separation. So which one do you think out of these 4? Let's start analyzing. Okay. So I'll be going with D. Clearly D is out because we can clearly see that there is all uniform. The phases are not separate. In case of C also, clearly we cannot see the 2 distinct phases. In case of B, yes, we can see that there are slightly different, but they are not strictly separate. So we cannot really separate out these 2 phases. So the clear-cut answer is A. Why? Because these 2 phases are clearly separate. Okay. So this could be, one phase could be solid, another is liquid or gas, whatever it is. Okay. So this is the correct answer. So what is the important concept? The important concept is that in case of heterogeneous, the 2 phases, they are separated, even though they have been mixed, but they are showing their separate existence. In case of D, there is a clear cut that it is like a uniform kind of this one. So it is like a homogeneous. Okay. But in case of this, it is a clear cut kind of 2 separate phases are in existence. So our clear cut answer is A. Okay. So I will say option A is the correct answer. Okay. Very, very simple. Okay. Very, very simple. Okay. So let's look into this second interesting question. What volume of carbon dioxide gas can be obtained by reacting with 1 dm cube of methane with 1 dm cube of oxygen? Okay, as per the equation. So what this equation is telling us? Okay, so let's start looking into this. it specifies that 1 volume of methane is reacting with 2 volumes to produce 1 volume of CO2 and obviously 2 volume of water. Okay, but we will consider only the gaseous, so we'll ignore this right now. Okay, so now so if we convert it into this, okay, so if we are having 1 dm cube, okay, of methane, we'll be requiring 2 dm cube of oxygen, okay, to get 1 dm cube of CO2. Okay, this is what is required as per the stoichiometric. Please be very, very clear. This is what is required as per stoichiometric equation. But now let's see what is available to us. What is available to us is 1 dm cube of this and 1 dm cube of oxygen. Clearly oxygen is in the smaller quantity, okay, because what was required was 2 dm cube, but available is only 1 dm cube. That means this is LR limiting reagent. Simple. Oxygen is the limiting reagent. So what is the concept? That in this case, limiting reagent is going to decide, or oxygen is going to decide how much it will be reacting with the methane. So obviously, as per the stoichiometric equation, oxygen needs half of its volume. So in this case, it is very clear that it can react with 0.5 dm cube of methane to produce 0.5 dm cube of CO2. Simple. Okay. Please remember the concept is of limiting reagent. Limiting reagent. So please remember, limiting reagent decides, okay, the production, okay, or products quantity. So always in stoichiometry, limiting reagent concept plays very, very important role. Okay, so in this case, oxygen is in the limiting quantity, so its quantity is going to decide how much production will be there. Okay, so very, very simple. So in this case, the clear-cut answer is A, or we can say option A. Very, very simple. Okay. Okay. So now let's look into the question number 3. What is the empirical formula for hydrocarbon with 75% carbon and 25% hydrogen? So what is given? Carbon is 75% by mass and hydrogen is 25%. Simple. Okay. So it means simple, 3 parts of carbon and 1 part of hydrogen. So let's start looking into this. So the first option A, it specifies C3H. So what is the atomic mass of carbon? 12. So 12 into 3, 36. Hydrogen is 1. Obviously this ratio is 36. So this is out. Okay, I'm just saying, let's put the ratio. So the ratio in this case is 36. Now let's look into the next one, option B, CH2. CH2, carbon is 12, hydrogen is 2, ratio is 6, out. In this case, the next one, okay, it is C2H6. So that is 24 and hydrogen is 6, ratio is 4. And let's look into the last one, CH4. Carbon is 12, hydrogen is 1 into 4, ratio is 3. And clear cut, this is what we are talking about, but because in this case, given condition, the ratio is 3. 75 divided by 25, that is 3. So this is very much meeting our requirement. So the winner is option D. Okay, option D. Very, very simple. Okay, very, very, very simple logic. Okay, let's look into the question number 4. What is the ground state electronic configuration of an atom chromium Z is equal to 24? Simple. Chromium, why we should feel that it is important? Because it is having an exceptional electron configuration. So let's look into it. Very, very simple. So what is the electronic configuration? So let's start putting it. 1s2, 2s2, okay, 2p6, 3s2, 3p6. How many electrons we have put so far? 4, 10, 12, okay, and 18. And now 6 are pending. Okay, now you need to be careful. That configuration will be 4s1, and here comes the d orbitals get introduced. Okay, so we can clearly say that this part belongs to argon, and then 4s1 3d5. Okay, simple. So just for your information, how this will look like, that this will be 4s1 and this is going to be 3d5. 1, 2, 3, 4, and 5. Okay, this is a completely half-filled orbital. This is what is important. Half-filled orbital. That's why chromium is very, very important. Exceptional. Okay, and typically IB always tries to test you with this exceptional electronic configuration. So you need to be aware of that. Okay, very, very simple. So which one we can think of, and a clear-cut option in this case is option C. Okay, very, very simple. So the answer is option C. Extremely simple. Okay, extremely simple. You don't need to remember anything. Only thing is that you should be aware of that half-filled orbital are more stable than the not completely. I mean, for example, if you would have shown like this, okay, if it is like this, okay, something like this, this is not completely half filled or not fully filled. So this is not going to be stable. This is much more stable configuration. Okay, and that's the reason that this is preferred. Okay, so you need to remember this concept. There is nothing else. Okay, very, very simple. Hi. So let's look into the question number 5. Okay, and the question is being asked, which element is represented by first 8 successive ionization energies on the graph? Okay, so first of all, ionization energy. What is mean by ionization energy? If you recap, what is mean by ionization energy, i.e., okay, it means it is energy required to remove one electron. Okay, obviously in the gaseous state. Okay. So it is basically the energy to remove one electron. Okay, that is how we create this cations. So now what kind of a trend do we see? So what we see that for the first one, first, second, third, fourth, fifth, okay, and up to the first sixth, there is a gradual increase. Okay, this is a gradual increase. It is increasing, but there is a gradual increase. While from 6 to 7, there is a substantial jump, quantum jump. This is what you need to pick up. There is a big difference between IE7, that means the seventh one, and IE6. So what it represents. So understand what it means, that this atom which we are being shown, it must be having 6 electrons, 6 valence electrons. Okay, then only it is possible. Why it is so? Because for 6 electrons, 6 valence electron, that means those electrons which are in the outermost orbit, okay, obviously there is going to be a gradual increase for every additional, when we are trying to take out additional electron. Okay, so that's why from first to six there is a gradual increase, because the effective nuclear charge is increasing. That means the attraction from the nucleus on the next electron, it is becoming higher and higher, so it becomes more and more difficult to remove that additional electron. But that is basically the gradual trend. But if it falls from one specific energy shell to the lower energy shell, that means it is coming closer to the nucleus substantially. And this is what basically is being represented by this quantum jump. Quantum jump means that now the next electron has to be from the lower shell. In case of the gradual, they were from the same shell. Okay, it clearly conclude, that means we can clearly conclude, that means this atom must be having 6 valence electrons, and the clear-cut winner is sulfur. Simple, because sulfur configuration is straightforward. If you recollect, it is neon and 3s2 3p4, straightforward. Okay, 3s2 3p4, these are the 6 valence electrons. Because as soon as you remove these 6 electrons, then we are looking into the second shell. Okay, second shell, and that means we are achieved the neon configuration, which is the inert or noble gas, and we know how the noble gases are stable. That means we are dealing with the second shell. So obviously there has to be a quantum jump. So the clear-cut answer in this case is option B. Okay, so the concept is very, very simple. Ionization energy, energy required to remove electron from the atom, okay, or an ion, okay, and that too in the gaseous phase. And it is clear, simple logic, that how difficult it is to remove, because the nucleus, which is a positively charged, it is always going to attract. Okay, so that is the logic. Hope this is quite clear. It was very simple. Okay, let's start looking into the question number 6. Appears to be very interesting. Which describes an atom of bismuth, okay, Z is equal to 83. Okay, so they have given us the principal energy level number and number of valence electrons. Okay, appears to be very daunting, but very, very simple. So let's understand. Okay, and our best tool is to look into the periodic table. So I'm just displaying this periodic table for your ready reference, so that you will understand. Very, very simple. Okay, and obviously it is provided in this. So what do we see now? Now understand very, very simple logic that in the first period, how many electron? Period means the horizontal row. So you can clearly see that there are 2 elements. In the second period, there are 8. In the third one, 8. In the fourth one, okay, how many do you see? Okay, you can clearly see that there are 18. In the fifth one, there are 18. And now comes the confusion. Okay, I won't say the confusion, but the thing is basically in the sixth one that we are going to get lanthanoids, that is the F block, and that's the reason that it goes up to 32. Okay, so now if we add up, okay, because we are dealing with 83 atomic numbers, so how many electrons? 2 plus 8, 10, 18, okay, 36, 54, 86. So let me see that how we can talk about 2 plus 8 plus 8 plus 18 plus 18 plus 32. This will give us 86 electrons. Okay, simple. And while the bismuth is having only 83, so it means that, okay, so let me put it, okay, very clearly so that there is no confusion. This is the period number 1, 2, 3, 4, 5, and 6. Why period number? Because that is going to represent the principal energy shell. Please remember, when we talk about a period, we are referring to the principal energy shell or energy level. Okay, what we called orbit, not orbital, or shell. Okay, best thing is to look at, say that principal energy shell or level. So it clearly means that the bismuth is in the sixth one. So it means the answer has to be between C and D. Okay, either this or this. So at least we are very clear. Now let's look into this, that how many electrons it is going to have. So up to this, now understand that up to this, how many electrons we have dealt with. Okay, so the answer is straightforward, that how many electrons we have dealt with so far. So let's calculate 10, 18, 36, and 54. Okay, 54 electrons we have dealt with so far. And then additional 29 electrons. But now comes the very tricky part, that not tricky part, but that you need to remember, that when we talk about the sixth period, we are dealing with basically F as well as D orbital. Okay, F and D orbital. Therefore, for the sixth period, it becomes a little bit challenging, but you need to remember, so that if you do the electronic configuration, you will understand the electronic configuration is going to be xenon, then 4F14, okay, 5D10, okay, and then 6S2 and 6P3. You can use this even using Aufbau principle, but this is the faster way of looking into this. Okay, up to the fifth period, we have filled up 54 electrons. Additional 29 electrons need to be filled up. So first we'll fill it up using 4F. Okay, you can look into the Aufbau principle of filling up, followed by 5D, and then the sixth period, this one, that is the sixth shell, that is 6S2 and 6P5. So how many valence electrons are there? A valence electron means in the outermost. So there are total 5 electrons. So the answer is this. So the clear cut, simple option, correct option is C. Okay. So what is the important point? Important point to remember, that you should be aware of what is mean by how to use the periodic table, what it represents. It represents in each period how many electrons can stay. Okay, and so this you can remember, 2, 8, 8, 18, 18, 32, 32. Okay, like that, simple. Okay, Hope this is quite simple and you must have understood it very, very well. Okay, now we are looking into the question number 7. Appears to be very interesting. Which series represents the atoms in order of decreasing atomic radius? Okay, so again, what is our best friend? Look into the periodic table. That will give us a lot of clue. Okay, so let's start looking into the periodic table. Okay, so our friend magnesium, then they talk about the beryllium. Okay, so please remember that when we go up the periodic table, okay, the atomic radius decreases. Obvious reason, because we are going from higher principal energy level to the lower energy level, so obviously there is going to be a decrease, straightforward. Okay, no question on that. And then when we go, okay, again from left to right, atomic radius decreases. Okay, simple. And when we go from left to right, the atomic radius decreases. Left to right, atomic radius decreases. Okay, so we need to now decide which one is the correct option. So the clear cut, in case of between magnesium and beryllium, okay, magnesium and beryllium, magnesium is the winner. Okay, so that is on the sitting on the top, followed by beryllium. And then we know from left to right, okay, left to right, the atomic radius decreases. Why? Because simple, because the effective nuclear charge is increasing. We are staying in the same orbit, okay, and so, or same energy shell. So effective nuclear charge is increasing. The shielding electrons are not creating any additional obstruction, okay, and therefore attraction of the nucleus continues to increase and it starts shrinking. So the clear cut, followed by carbon and then nitrogen. This is the order. The clear option, simple option is D. So which concepts we are applying here? Just for your, okay, let me state it, option D. So which concept? Up, okay, up the group, decrease, and left to right in period, decrease. Okay, so this is the concept we are applying. Up the group, very, very straightforward, because we are going from higher energy shell to lower energy shell. Okay, that is obvious. While from left to right, effective nuclear charge is increasing. You can always refer to our course, okay, which clearly explains. Okay, we have specifically put the separate topic on how to look into these various concepts like effective nuclear charge, shielding by the electrons. Okay, all these interesting concepts we have covered in our course. So please do visit, okay, our website and you will find those courses very extremely helpful. Okay, let's look into the question number 8. Okay. Which electrons are removed from iron Z is equal to 26 to form iron 2, okay, ion. So what they are asking is this, that which electrons are being removed. Simple. So let's do, always important is to have an electron configuration, 1s2, 2s2, sorry, 2p6, 3s2, 3p6. Okay, and now I'm highlighting specifically that where you can go wrong, 4s2 and 3d6. Okay, so please understand this is the filling order. Okay, when we fill up the electron, first after 3p6, okay, as per the Aufbau principle, okay, 4s will be filled up, 2 electrons, and then balance 6 electrons are filled up in the 3d. Okay, the reason being that 3d orbital, okay, it is at the higher energy level than 4s. But when we remove the electrons, now just be careful. When electrons are being removed, that means the ionization, electrons are first removed from 4s. Okay, this is very, very important. Why? Okay, now why, you may ask. The reason being that after filling up of the electron, that means 4s2 and 3d6, then 4s orbital goes into the higher energy level. Before filling up, 4s is at the lower energy level. But after filling up of the electron, 4s orbital goes slightly higher energy level as compared to 3d6. And then we know that when we take out electrons, obviously we go from the higher energy level to lower energy level. So since 4s orbital is at the higher energy level, so electrons are removed first from 4s. Okay, please remember this as a concept. Okay, always remember, especially when we talk about s and d. Okay, the s orbital, 4s orbital is, even though when it is not filled up, it is at the lower energy level, but after filling up, it goes at the higher energy level. And that's why while taking out the electrons, okay, the electrons will be removed from the 4s. So what kind of a configuration it will look like? Very, very straightforward. So the configuration of Fe2 plus will be like this: 1s2, 2s2, 2p6, 3s2, 3p6, and what is left is only 3d6. Okay, this is this one. Okay, this is Fe2 plus, and so the correct option is simple B. Option B. Extremely simple. Okay, very, 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 very simple. Okay, now let's look into this question number 9. What is the order of increasing boiling point? Very interesting concepts. Okay, so this will help you a lot in understanding. So which compounds we are talking about? CH3, CH2, CH2, CH3. What is this? This is simple N-butane. Okay, there is nothing. It is nothing means it is a non-polar, because we know in case of alkanes, there is only carbon and hydrogen. There is no electronegativity difference. So these are non-polar. And we know boiling point means it is all about how strongly the two molecules can stay together. Okay, or is there any strong attraction, IMF. So please remember this, when we talk about the boiling point, we should be, the real main concept is IMF, intermolecular force of attraction, or what we call van der Waals forces. Okay, this is the very, very important concept, van der Waals forces. So in case of this alkane, there is nothing, okay, because this is a non-polar, so it is going to be the lowest. Okay, so first let's understand that which options we are talking about. Yes, so that means straightforward C is out. Okay, this is gone. We are not going to even talk about this. Okay. Now let's look into the another compound. So which is the another compound? That is the CH3 CHOH and then CH3. Then we talk about CH3 C double bond O CH3 and then CH3 C double bond O OH. This is nothing but our ethanoic acid. Okay, this is nothing but what we called our propanone. Okay, and this is nothing but propantool. Propantool. So how to decide? Very, very simple. Okay, very, very simple logic. Important in this case is to look into the very important concept for IMF. It is all about hydrogen bonding. Okay, so because oxygen is electronegative, it will grab the electron from this hydrogen. Okay, and there will be a delta minus charge. Now these two, okay, this oxygen can get attached to hydrogen from the other molecule, and besides that there is a double bond between carbon and oxygen. So again this will carbon will be delta plus and this will be delta minus. So in short, there are a lot of polarity which is getting developed. Okay, so and therefore there are two oxygen atoms, okay, which are having partial negative charge, which can get attached to hydrogen from the other molecule. Okay, that is a simple logic. While in case of the propantool, oxygen, okay, there is definitely a possibility of hydrogen bonding, because what is hydrogen bonding? Hydrogen bonding means whenever hydrogen is attached to FON, three most electronegative atoms in the periodic table. So in this case, it is attached to oxygen. So definitely there's a hydrogen bonding which is possible. So definitely this is another candidate. But this is going to be the winner simply because there are two potential sites of oxygen. There is delta minus for this carbon double bond. This is basically a carbonyl group, as well as OH. While in this case, there is only one, and which is not going to have a much stronger as compared to propantool. So in this case, the clear-cut winner is simple, this option B. Okay, so the leader is ethanoic acid, okay, followed by alcohol, propantool, then propanone, and then butane. Okay, so the correct option is B. Okay, so which concept we are dealing with? We are dealing with hydrogen bonding concept. Okay, so it should be very clear. Okay, very, very simple. Let's look into the question number 10. What is the IUPAC name of NiCO3? Okay, I think this is a cakewalk for you people. Nickel carbonate. So how to look into this? Very, very simple. Okay, nickel, okay, carbonate radical, okay, CO3. We know that its charge, okay, oxidation number overall it is -2. So that means nickel must have +2. Simple. So what should be the answer? Very, very simple. Okay, the clear option is option A. Okay, nickel 2 carbonate. Why? Because carbonate radical is having overall -2 charge. Okay, and I have already explained in our course that what are the typical charges which are prevailing on the common radicals like carbonate, sulfate, nitrates, etc. Okay, so that you need to just memorize. It is simple and it is expected that you must memorize this. So just by knowing this, it was like a cakewalk. Okay, you can easily grab this 1 mark. Simple. Okay, hope this is clear, and please remember that do visit our website, because on our website we have explained so many simple concepts in our courses. Okay, and so, and besides that, we do provide at Leadib Academy, we do provide one-to-one online teaching. Okay, so that you can further improve your grades. Hope this was quite interesting one.